Abigail is a professor of information at Michigan. She got her PhD in computer science at the Colorado Boulder, and she spent time researching at Microsoft Research as an NSF graduate research fellow. She has a BA in methods and social sciences from Northwestern University. And our work is very broad ranging from network science to fairness in AI and ethics. And I think it's really important work. So we're super excited to have her talk here because the complex systems, is data science and complex systems. And ethics is a very strong, and fairness is a strong part of this. And so we're super excited to have you tell us about the cutting edge in this field. So I will let you share now.
All right, let's see. I realized this worked before, but. All right, do you see the slides or the presenter notes?
We do.
The slides, great. All right, excellent. So thank you for having me. I think this is a really fun seminar. I'm actually a professor of information and a professor of complex systems. So it's really nice to, sort of be in these kinds of interdisciplinary environments where we have, sort of folks who want to be thinking about all sorts of different problems, really taking a systems perspective. And so I actually am sort of taking the excuse to talk about sort of a few different projects, all of which are sort of fairly new, because I think this sort of systems thinking approach is really important for thinking about what we might call sort of responsible AI. And so I'll tell you a little bit about how I came to that. Anyways, so I wanted to cover more ideas because I think this is a really exciting intersection of spaces. And in fact, my training, I've spent time working with social scientists. I have a degree in computer science. I really started spending time around this with fairness, accountability, and transparency, space, and machine learning. And it could have seemed like, I actually got questions like this when I was on the job market. I was like, oh, well, maybe you're a computational social science person, or maybe you're a complex systems person, or maybe you're a fairness, accountability, and transparency person. What does it mean to do work in 3 different fields? And I was like, well, I don't know. I think there's a whole lot of overlap. And so for me, I really came at this coming from thinking about organizations and social networks and the emergence of inequality, measurement and governance, and thinking about social structure, thinking about systems. And I would put all of these things in all of these, circles. So I do think there's sort of a lot of potential and a lot we can do sort of with this shared set of perspectives. So I think these are sort of inherently systems problems. In fact, what we might call responsible AI, which I'm using pretty loosely, lots of folks mean lots of different things by responsible AI. It's a systems problem. And so what that means is, we're thinking about sort of the structure of our social world and how that shows up in the structure of our technical worlds that we interact with, and how our technical world gets shaped by our social world and vice versa. And so if you want to design a system that is, say, responsible or not harmful, or then it's really important to think about it as a system. Another looseness of language I'm using that I just want to flag, I'm going to slip between things like AI and broader computational or algorithmic systems. Generally, I'm thinking about systems that kind of have, even a fairly trivial amount of artificial intelligence or machine learning in them, but the sort of networks of platforms and systems and sort of decision making and ads that get served to us, and platforms that show us our options. I'll give you some really concrete examples in a second, but I just want to flag that I am being a bit loose with that kind of language. And I think that actually reflects how something like responsible AI is used in practice. So do with that what you will. So what do I mean by responsible AI, sort of where we see this happening in practice? Every week you can come up with new examples, but let me just pick a few older ones, but I think that are evocative. I don't know if any of you saw this on at the time on Twitter. There was a thing going around where people would post, a photograph, and the Twitter algorithm would zoom in on one part of the photograph. And so, they would use these sort of this setup where it was like, okay, kind of the same picture. Maybe it's like it focuses on the person at the top, or maybe it focuses on the center of the photograph. But in fact, what we got with this is that we got all these pictures of Mitch McConnell everywhere. And so, this led to sort of fairly quick change, partly because it was able to be so visible, so easily tested, really sort of quickly auditable from like a citizen standpoint. And, it was on the platform itself that needed to do the change. And so, so they actually, were able to, basically what ended up happening is they like turned off their automatic cropping system. We're just like, oh, no, we're just going to treat the photos as is. And so I'm not quite sure where it is now, but I think this was an important instance because it was so, again, just like visible and easy to interact with yourself, whereas often it's sort of more indirect, or it's harder to see where some of this happens. For example, all sorts of hiring platforms now, you go through this interview process where you use, say, video interviews, and it looks at things like, your expressions in a really sort of in a way that's sort of strongly related to race and neurotypicality and all of these sorts of things that you really don't want to be hiring based off of, but we have built into these kinds of systems. And so these kinds of systems keep getting audited, but it's really hard to get at some of this, and hard to know what the issues are. And maybe it's actually that there's an animal in the background of my screen and now I'm no longer hireable, and or maybe it's actually that I'm poorly lit in a way that is related to my SES. Who knows? All of this gets built in, but so other people have worked on these kinds of examples. I'm just giving these as sort of things to be thinking about as ways that we see, again, the sort of social structure interacting with these computational systems. There are lots of talks that are great about sort of bias in AI and what this all means. And I actually don't want to go too far down that, because I want to show you what the sort of systems perspective can bias in this space. Beyond getting certain jobs, there are well-documented biases and just sort of significant errors and just sort of invalid tools used in facial recognition and all sorts of facial analysis kinds of tools. So in Michigan, this actually sort of led to an arrest, but on a different scale, on a sort of wide scale. So we have the sort of the individual impact, and here we also have these sort of larger scale impacts. And this example, I think, is compelling for a certain reason. So, so here, these folks, Obermeyer et al., did this kind of audit on on one certain commercial prediction software used in a healthcare system. They looked at one system, but it's sort of comparable to other ones being used across the country to look at who should be given entry into this sort of high care healthcare management system. So like you could get additional access to healthcare, additional supports if you were seen as someone who like needed, was going to need more support, more access to healthcare, more support going forward. And so the way they did that was to look at, who do we want to give these extra resources to? We want to give them to those with the largest future care needs. And they modeled that based on past care needs, which they modeled on past care costs, which meant that those who had been sort of systematically underserved or limited in access to healthcare seemed to have lower costs, despite being sort of the same health or even less healthy and sort of more in need of this kind of tool. So as a result, sort of, healthier white patients were getting access to these services, and sicker Black patients were being denied. And so this, this disparity got sort of really fundamentally built in by the assumptions from, we know there's inequitable access to healthcare in the United States. And we know there are these differences with race, and so we know that these sort of social patterns could exist. But here, the thing that was being modeled was different than the thing that was actually happening. And that really sort of led to this mismatch between, right, future care needs being about, ostensibly about sort of future health needs, and ending up being on, again, this sort of past access. So what is all that to say? So I am going to draw a little bit on this sort of sociologist who has taken kind of a complex systems point of view to think about organizations and crises. And I would assert that these kinds of AI accidents where, oh gosh, our hiring platform is biased, and oh gosh, we sent the wrong person to jail, or we didn't give them access to healthcare, right? Really sort of significant things going wrong are really treated as, actually, it's just, sort of a matter of the technology. Like these are like, if we just like tried a little bit harder, we could have fixed it. What we really just were missing was, we just need to like capture that edge case, or make sure that we have more training data so we don't only look at these kinds of faces. That there's kind of just like there's like a concrete fix to this. And so there was a classic example with the great title from the sort of tool in natural language processing called word embeddings, in particular looking at this sort of shows up when you look at machine translation or look at other kinds of sort of language related tasks. And so these folks looked at sort of how natural language sort of ends up encoded in these spaces, and you can actually recover these these relationships, like analogies, and you can use that to say like, actually, man plus like employment vector takes you to computer programmer, but for woman plus that employment vector, it takes you to homemaker. And so how do you debias this? You just subtract off that like gender vector, and then it's fixed. And so that was their solution. It was like, great, like we can fix the sexism. You just subtract the sexism vector. And I guess if there are other things, you could subtract off those vectors too. And so that's this like Band-Aid exists, we didn't try harder, but now it's fixed. And, I think it part of the value of this paper, I think, is partly just, the title and being a result that they found just being sort of so truly evocative. And so what I think is, interesting. So actually these two papers were presented together at this Fairness, Accountability, and Transparency Conference in 2016, back to back, because they used the same data sets and same methods and to come to opposite conclusions. So I think this is sort of a really interesting example this way, because they looked and said, yeah, when we look at human language, sure, we find like these gender relationships, and this also maps into how we talk about nature and how we talk about our sense of smell, like how we sort of experience the world and code culture into language, that it's not going to be, you can subtract off these vectors because it's so sort of inherently deeply nested into these kinds of systems. And so, yeah, so I really like this kind of example as, it's tempting to have the, sort of just subtract off the sexism vector, but of course, turns out we've got some more complicated processes. So what we draw on, or what some of my work with, that I'll talk about a little bit later about sort of system safety, is there are actually these examples from sort of, there are descriptions of sort of these system failures where actually, here we're talking about a lot of these systems where they're kind of probably like doing what they're supposed to do. Like these systems aren't like misperforming by showing these kinds of faces or a lot of this kind of healthcare. And they're actually sort of doing what they're supposed to do and trained to do, because, they'll do what they are told based on the data that we have and the assumptions that we built into these systems. So in some of my work, I've been working with someone at Microsoft Research, where we talk about sort of how these harms emerge really from like this disconnect between these intended and the operationalized constructs. So they're just borrowing from the mathematical social sciences, we care about like, these future health needs, and we're using past care costs. And, it's in that disconnect is really where we're sort of creating this potential for harm. And so in how we think about sort of debugging these systems, or, preventing future harms, being able to understand what assumptions are going into our data and our systems is really super important. So we talk about some of it there in our work on measurement. But really, I think this points to this larger conversation. Nancy Levison is this wonderful systems safety scholar who's at MIT. And so she's been writing about all sorts of, from software to airplanes to whatever, lots of industrial accidents, but this shows up in lots of places. And, sort of makes a strong point that you can have a system full of, reliable parts, but that does not sort of guarantee a safe system, or even just reliable parts does not necessarily create a reliable system. And so that is a very, familiar story for those who are used to thinking about complex systems of like, yeah, I have all of these individual pieces that work this way that I'm familiar with. That's all right. Like, of course we might think about how bad things might happen, or how unintended things might happen, or, just following the rules as we're given, we might end up with these sort of interesting kinds of outcomes. And so what I think is interesting about these AI accidents is, when they happen, again, it's these systems are working as they're supposed to. And what ends up really being the problem is that they reveal something about our underlying social structure. Like, it's not the healthcare algorithm in some ways, it's the like, extremely like differential lack of access to healthcare. That's the problem. Our access to opportunity, all sorts of, or, who is building these systems, all sorts of these examples. So in a lot of ways, it's less about, the system itself, but actually it becomes a problem when it reveals this underlying social structure. So that means it's helpful for us to be able to think about sort of what that sort of social structure is and how it shows up throughout the process of designing, implementing, debugging, trying to intervene upon these systems and so on. And so again, this reveals, it's that it reveals something about the world around us that we would not like to see, and it potentially amplifies those harms. And we also tend to, and sort of those who are sort of likely to be marginalized prior are likely to be even more so from this. And we often sort of extract high costs for being the people affected by these systems, or even sort of how we think about testing. So just want to flag that. And I think Sally Haslanger is a philosopher who's sort of written a lot about sort of structural explanations in this space in a way that I think would resonate with a lot of folks here. But I think, the sort of the argument between these sort of system scholars and reasoning about these kinds of sort of system problems ends up being that, like, yeah, you have to think about these sort of the structure of what's going on. And so, it's possible that some of the, technologies have aspects that are fixable, but like, right, the sexism vector, like the sexism is, a hard thing to get rid of. We've got this sort of this like very durable inequalities in our society, which is just true. And so we have to, consider how that shows up, not just like, in the proximal sense of, the bias in this data set, but actually how, what kinds of implications these systems have, or who gets affected and to what degree, and really sort of what that buys for us, really like why thinking about the social structure and how sort of systems came to be the way they are, or how these harms actually get enacted, really requires this sort of like systems structural kind of thinking. So the sociologist who likes thinking about these accidents, I think ends up in the right place by saying like, yeah, the issue isn't, we're worrying about these accidents, these sort of potentially catastrophic failures. And the issue is not risk per se, it's not preventing that per se, but thinking about power. And so reframing towards thinking about power, thinking about those impacts is really, I think, an important takeaway. And so I want to use that sort of basis to talk about a few things I've been working on and I'm excited about, and I think sort of point to the ways that we can use this perspective. And I've already been sort of suggesting this in what we've been talking about so far, that, I think actually moving the conversation beyond just, is it a biased system? Is the data biased? Is the model biased? There's a lot of emphasis and concern about bias, which is not wrong, but can be sort of the wrong focus. And it's really the space of algorithmic harms that we're worried about, whether they're sort of fairness related harms, things where we're worried about sort of inequities, or really just sort of finding ways to make legible the kinds of impacts that we're worried about. And so what I like about those initial examples with like the Twitter cropped photo faces versus like the healthcare algorithm versus the individual outcomes, how you get to observe those harms is different depending on those settings. But I think you get to reason about the systems, why they are the way they are, in different ways if you're focused on the harms that you're trying to intervene upon or harms that you're trying to prevent. Right? Wouldn't it be great if we could catch everything in advance? But things change. And actually getting to that larger point, these like algorithmic AI systems, whatever, they're social and technical or socio-technical systems. They have moving parts. It's a complex systems problem. Here we are. And so, yeah, what does that mean? This is all of these things combined. We're working with these like tightly coupled systems. Emergent phenomena, things can be easily exacerbated, everything's related. We've got these sort of durable social structures. We've got, potentially some kind of like computing information processing happening at various levels within this. And things are changing, things are dynamic. And so I have been sort of using this perspective to think about how we actually locate these algorithmic harms and how they play out, focus on these feedback loops and actually where we can borrow some of these lessons from system safety. So this is going to be like super fast, but and high level, but I just wanted to, I was excited to sort of connect with you all about the sort of breadth of opportunities, I think, with this perspective. And it's just things that I've been working on that I think are fun. So we're here now. All right. So thanks for joining me. So we've been thinking about this at a few different places, thinking about how these like feedback loops of, how like these algorithmic harms actually sort of become instantiated. And so one of the areas we've been thinking about that is thinking about hiring systems where there's some kind of implicit ranking system. So if it's thinking about the US mortgage market and how sort of different processes in both disinvestment, but also in lending strategies has, exacerbated certain kinds of harms. A kind of different kind of project, but I think is actually, or you could call it different, I think it's part of the same conversation, has been thinking about like meaning making in science and how we use certain variables and how that changes their meaning based on how we use them in science. And then we're putting together some of these lessons from other fields that have been thinking about the kinds of disasters that we want to prevent, where it turns out, in some ways, algorithms or AI like isn't so special. So yeah, all right. So let's go on our quick tour. Maybe I'll take a sip of water, but awesome. All right, so hiring platforms. Here we have, here I'm thinking about something like ZipRecruiter or LinkedIn or Monster. And they have two sides. We've got job applicants looking for jobs and recruiters looking for job applicants. With hiring platforms, they're trying to mediate or sort of allocate exposure. So here are the job candidates I want to show you based on what you've searched for, or here are the jobs that you searched for. But if I'm a recruiter and I'm looking for people to hire, I'm like, okay, I want to hire a software engineer. I'm going to search for like, people with software engineering skills. And the platform is going to say, here are some candidates that you should look into. And June 2021, CEO of ZipRecruiter saying, I believe we're as close to a merit-based assessment of people as can currently be done. So, right, there's strong belief and intent to have these people ranked in some kind of order, returned in some kind of relevance-based way to, serve up potential employees. What could go wrong? What could go wrong? So, for example, right, we're building in all sorts of historical patterns. We're exacerbating those. For example, right, so we know that men are more likely to apply to more ambitious jobs than women, or jobs that they have sort of fewer of the qualifications for example. And so recommendation algorithms don't know what's happening. They don't just pay attention to behavior. So they'll skew, who's applying to these jobs should be shown those kinds of jobs. Similarly, sort of biases in who the searchers are clicking on also sort of feeds into their future behavior. Anyways, you can imagine how this thing could not necessarily spiral out of control, but, spiral not in the direction we want it to. But fortunately, a lot of work has been done in thinking about ranking systems and building ranking systems. That is to say, like sort of these search-based systems where you say, like, I want to find people that are relevant to this. A lot of work has been done to sort of say, like, well, we know humans are biased. Like, they're more likely to click on like the first person in the list. And we know that there's, weirdness in, how noisy these are, or how, like, there's a lot of concern about actually how we build good ranking systems to return these relevant results. But there's really a lot of assumptions about behavior that get built in that these kinds of examples really reveal that, they might be good at accounting for the fact that, people like to click on whoever the first result is, but there are other kinds of biases that are going to be less well accounted for. And sometimes they overlap and sort of can exacerbate these problems. Sometimes they can sort of cancel out in testing in a way that can make you feel like maybe you're doing okay. So with some folks who work in information retrieval, Aparna Balagopalan and Abigail, we have been looking at sort of what it means to actually sort of allocate exposure. That is to say, like, here's how I'm going to show you these different users based on how most of these systems work, something like click-based relevance. And, actually, if you write down even just some of the assumptions that you kind of need to get right, you can really start to test, like, well, if this assumption is actually broken, like, how bad is this for the system, or sort of how much does this mess up what we see, or actually do we sort of compensate for this by, say, accounting for novelty or adding noise or so on. So and if we add, say, a post hoc fairness fix, sort of our search ranking equivalent of subtract the sexism vector, does that actually accomplish what we want it to? Are there sort of meaningful trade-offs in, say, like quality of the rankings, which we can talk about, but, quality of the rankings versus different kinds of these measures and what it means to break these assumptions. So those results are a little bit more mixed in nuance, other than to say that it matters when you break these assumptions, and not necessarily in obvious ways. But I think there's, I think a real value to, again, sort of thinking about the process of through which, for example, these like rankings, this sort of the allocation of exposure gets laid out in order to understand things like, right, when the CEO says, no, we understand what merit is, or, something happened and someone audits the system and we find out actually there is more bias still, I think there has to be this kind of work to understand how we got here. Otherwise, we're going to keep doing the Band-Aid fixes. And in green, I sort of keep pointing to a few papers, totally non-exhaustive, but these two I found sort of relevant and interesting. Sloan et al. Thinking about hiring in Silicon Valley and sort of the challenges of auditing. And in this, and what I'll talk about next, Alana Zaidi actually has this, she's a legal scholar, and she writes about the silicon ceiling, the way that, which I think is a great name, thinking about sort of the ways that access to opportunities can be allocated, and in ways that sort of build up over time. So if you imagine in this hiring setting that, you know, you're only being shown a certain kind of job, then that is going to sort of limit your future opportunities. And so she shows how this plays out in a bunch of different kinds of systems. But, you know, you can imagine how limited opportunities in one domain can limit your future opportunities in another. So speaking of which, yeah, let's think about those like linked computational systems and the allocation of opportunity. So this was really, again, sort of, we were really motivated by this sort of silicon ceiling idea, because it really felt, again, like this sort of, you know, system understanding of how, you know, if I'm like going to go through some, you know, if I might be algorithmically sorted into a certain bin or not even shown certain opportunities because of that, or, you know, based on my inferred credit score, I'm only going to be shown these kinds of products, which means I now have this sort of even worse prospects for what I can engage with. Anyways, all sorts of ways that, again, durable inequality. Yeah. But also just ways that this can now be encoded in certain ways. And so this is with my awesome student, Lou, who's at the University of Michigan School of Information. And we looked at specifically the US mortgage market and how actually these sort of harms of opportunity play out. And some of it in sort of expected ways in terms of exclusion from opportunity, and others that some other folks have written about in ways that, you know, when there are sort of kinds of inclusion, this kind of what you could call predatory inclusion, but sort of generally these settings where, you know, by giving access to someone to, let's say, a borrowing opportunity or a neighborhood, it fundamentally changes the sort of nature of the market. And so based on the sort of both history of the mortgage market and sort of racialized disinvestment in different areas, you get, you know, these sort of very clear, you know, reinforcing patterns of sort of limits to opportunity, creating future limits to opportunity. And this then shows up in certain ways within, you know, algorithmically mediated lending systems. I was talking to Jean-Gab right before this that, you know, I bought a house during the pandemic. And so my student was doing this reading and, you know, I was sort of showing her some of the things that I was like, had to do for the mortgage process. So this did not help me buy my house, but it did, you know, but it was also very clear that I was going to be in a very privileged position going through that system. And that, you know, there were going to be these sort of systematic ways that that was going to be true. And that was going to look different if I was in Ann Arbor, Michigan, where I am right now, or Ypsilanti, just the neighboring small city next door. And so anyway, so really interesting domain where I think people like to use these like lending examples sort of abstractly, but it turns out actually sort of the specific structure of the US mortgage market. You know, I guess it's, for us, it was actually the problem became more exciting as we got into those details. And I think that's a real opportunity rather than just treating these as sort of like surface level examples. All right, last one, which again seems like a jump, but I don't think it is thinking about this like meaning making in science. And so this is a super fun project with Jeff Lockhart, who is at Michigan and is going to be a JSMF fellow starting this summer. So very much in the complex systems community, and Andrea Thomer, who studies knowledge infrastructures. And here we're thinking about how things like variables for race and sex are included in neuroscience, or these in clinical medicine, how there are things like race corrections, or, you know, basically like ways you can modify scores based on like, okay, I know some, say, demographic information about you, or here's your genetic test to tell you that you're this percent this. And sort of the ways that those variables get kind of distorted and like sort of really, again, sort of like this change of meaning to, in kind of a systematic and slow moving way. And here I actually do mean sex and not gender. Gender is also, right, race, socially constructed, gender, socially constructed. Sex is often sort of left to the biologists, but it is itself socially constructed, and sort of what we say about like these hormones are female, or these, what becomes sort of like the current state of the art understanding of gonads or whatever, is sort of culturally specific and changes over time. And so that really, and so, this, so this takes you to all sorts of dark corners of the internet, but which Jeff does a lot of work paying attention to. But you really see this play out in a bunch of different ways. And, something that we sort of noticed was, there are folks who are trying to explicitly argue that, these like race differences or sex differences in biology, for example, are real. And then there are folks who are trying to sort of explicitly argue against those sort of traditions of like feminist biology. Other folks are sort of not necessarily engaging with that and trying to say like, hey, don't use biased data sets. Like, that's bad. Here, let me show you that your data set is biased. Look, these x-rays like predict race. So now I know that hand x-rays reveal race. And so those, certainly reinforce the sort of these like essentialist biological narratives of how we understand race, because it seems like experts are saying that, these x-rays of hands, those belong to one category versus another, and that it's predictable, therefore it must be real. And so we actually see in all sorts of settings, like then the white nationalists come in and sort of use this to, or white supremacists, pick your favorite group, comes in to actually sort of like co-opt those arguments and say like, well, look, this means these differences are real. And you see this play out with how folks respond to genetic ancestry testing. Jeff has done a lot of work in thinking about neuroscience and associate, like male brains versus female brains, for example. And then finally, actually, what I think is extra compelling and subtle is that, these variables then get built in as like benchmarks. So you want to show that your like clustering algorithm or your classification tool works, and you say like, well, I want to do this other task to predict something, but I like, as a gold standard also, like, well, it should detect the differences between men and women, or I'll like build that in as like a default assumption that like, well, we know those are different brains, so we don't even have to like test if there's a difference, we can just build that in. And so all of these have sort of a different like moral valence, I would say. But all of them sort of have this like specifically like not only making these categories real, but really this like biologizing nature. So like, brains become sexed and like hands have race. And so it really sort of is this like biologizing process of like putting these things in the body and sort of putting the sort of categories in the science in a way that I think is really interesting. And so we see this as actually like, again, part of this larger conversation about these algorithmic harms and how things happen, how categories get enacted, that we just think is really interesting and important. So yeah, that's been this super interesting project. And actually, I can talk more about this offline, but this actually sort of aligns well with a lot of actually like the history of science and people arguing about objectivity and what is objective. And actually these kinds of human classification problems have always been a problem for these objective systems. And so, yeah, anyways, we can go deep on that. All right, so yeah, I know this is like a bunch of different things, but I want to talk about like why I think it's all sort of the same program of thinking about these algorithmic harms within this complex systems view. And just because I mentioned it, these lessons from system safety, I think also, we know that these are systems accidents that reveal social structure and that we need these structural explanations. And, complex systems refrains like we don't have to start from square one, and actually like we know a lot about systems that we can draw on to actually help how we can think about building better or not building or regulating or preventing harms, or, pick your favorite. And so we dig into some of these like lessons from systems engineering and safety. My collaborators on that are, one is at Google and one is at the Naval Post-Secondary School. And so they have sort of these like interesting applied examples that they like to talk about. So yeah, I like working with people who have cool examples, and then we get to nerd out and find algorithmic harms everywhere. So yeah, I already talked about, I think responsible AI, beyond these systems problems, as we saw, this shows up in, really literal access to opportunity in ways that sort of build up over time. And I think sort of understanding the process of how these harms are enacted, I think is sort of like a really important contribution of the complex systems perspective. So yeah, so thank you. That's the whirlwind tour. I have these are some of the collaborators that were on all of this work. And this is like a super, super limited list of resources, but Abiba Burhane does this great work on draws on complex systems as well. Ruma Benjamin thinks about race as technology, and Dorothy Roberts, we really drew a lot of inspiration from with several of these projects, and Deb Raji on accountability and systems. So anyways, some great folks if you want to learn more. Yes, thank you.